In this segment, we're going to talk about Java variables. Now, if you're coming from PHP or a similar language, Java variables are going to seem more complex to you than the types of variables that you're used to. Now, the reason for that is Java is a strongly typed language. And what that means is each variable is associated with a data type. And that data type tells the Java compiler how much memory to allocate for that particular variable. For example, a simple integer uses less memory than a floating point number that's got a decimal point and additional numbers after the decimal point. So let me show you how to declare a variable in Java. It's actually pretty easy. What you're going to do is declare the variable type, in this case an integer, and then the variable name. So let's say age. So that's known as variable declaration. We'll put a comment in here. And we also have variable initialization. When we initialize a variable, we set the variable's initial value. Oftentimes, we can combine initialization and declaration into one step like this. So if we have a double variable, which is a type of floating point variable, actually let's do it as a float. So we have a floating point variable, and let's say the value is GPA, and we can set that to a value all in one line. So that's combined declaration and initialization. Most programmers do it this way. They combine declaration and initialization unless they have a specific reason not to. So integer variables, like I said, are variables that have just a value associated with them but no decimal point. Floats are another type that's allowed in Java. Now, these types of variables that we're going over are known as primitive variables. And that's because they don't have an actual class that they're a member of. They're just a primitive part of the language. Now, to be honest, most of these primitive types within Java have an associated class that can be used with them. They can be converted to that class pretty easily. For right now, just think of these as simple variables. So we have, so far, our float, our integer. We also have a byte variable. And of course, that uses just a byte of memory. And that holds a value between negative 128 and positive 127, representing the values that can be held in a single byte. So let's say here a good value to hold in a byte might be a score. And it would have to be a low score, so let's say 12. That fits within a byte value. A short is basically a small integer, an integer that uses less memory. So that's an integer between positive 32,767 and negative 32,768. So we could say short tennis score. I don't know why I'm thinking of scores today. 30. And then we have a long, which can be a much bigger integer. And its value actually has so many places. It's beyond billions. It's beyond trillions. It holds a very, very large number. So we could say, for example, your social security number. And so, I don't know, 050162727. Actually, this wouldn't work real well because of the leading zero. The leading zero would be eliminated. So let's actually change that to 6. I usually hold a social security number as a string variable, one that isn't a number. But for our purposes right now, that long works just fine to demonstrate it. We've already talked about the float, and then we've got a double precision float. Basically, a float is a 32-bit floating point number, and then our double, which I'll put right here, is a 64-bit, and it's what is called 64-bit IEEE 754 floating point. So we could say here precise number, and we could assign that to value, I don't know, 1.0007 or something, and then we've got to cast that back like this. So actually we have to cast the float back like this. I should be clear. So that casts the float value here, this 3.77, as a float. Otherwise, it'll be recognized as a double. So if we don't have this F here, this value is a double. Otherwise, it's a float. And it's a little bit confusing. Just remember to put your F after floats, and for most applications, you'll be just fine. We also have Boolean values. Now, Boolean values only hold two possible values, true or false. The way we declare a Boolean, we can say is playing, is just like that. So that declares the Boolean as true. And then finally, we have a character value, or sometimes called a char. And that holds a single character and is surrounded by single quotes. So there you go. We also could put in there, for example, a Unicode value with like \U and then the specific Unicode value like 0000 for 0 or something like that. So those are our primitive types. We have the integer, we have the float, and again, don't forget the F to convert this kind of double value into a float. We have a double, a byte, which is between -128 and +127, a short integer, approximately 32,000 to -32,000, a long number with lots and lots of capacity, a Boolean, which is only true or false, and then we have a char, which is a single character. So those are your primitive types. Now, to use them, we can simply print them out with println, and println will automatically convert them into a string in this case and output it. So system out println, our integer value is, and we're going to say age, just like that. And let's do this. I'm not going to do all of them, just to give you an idea. Our floating point value is, and we called our float GPA, and system out println. Let's do our Boolean. Our Boolean value is playing just like that. All right, and actually let's leave a little space here so we have a space between our actual string output right here and then the output from our variable, like our output from our variable from GPA or is playing. All right, I think we can go ahead and save this, and let's bring up our command line, and let's look in our Java folder. It looks like we're already there. And there we've got variables.java. So because we have the package declaration, we've got to do it with -d dot, and then the actual name of the file we're compiling, which is variables.java. And let's see if that came out okay. Just a minute, that should compile. And ls, and there is TV again. So we should be able to run it with Java tv.learn to program .android course .variables. Now you can't use tab to autocomplete when you do that. And there we go. Our integer value is 37, looks right. Our floating point value is 3.77. There it is. It drops the F. That's, again, just to let the compiler know this is a floating point value. And our value for is playing is true. So it looks like we output all of those values correctly. Now, there's another thing we need to be aware of when it comes to our variables in Java, and that's the operators that work on our variables. Now, whatever programming language or programming experience you're coming from, the operators are basically the same. So we have as our operators, and I'm just going to go ahead here and put this in a comment. So operators. We have, of course, addition, subtraction, multiplication, and division. I know you know those. We also have, for example, an operator like this, plus plus. So what that is that's the increment operator. It adds 1. We have a decrement operator which subtracts 1. We also have the modulus operator, sometimes called mod. Now that's the remainder after division. So those are your basic arithmetic operators. So we have our arithmetic operators. Let's try a couple of them. So let's go ahead and let's take our integer value age. And let's say system out print line next year I will be. And then that's plus there means concatenation. We're essentially gluing the string and the variable together. Plus plus age. Now I put the plus plus to the left of the variable. And what that means is we're going to evaluate this, meaning add 1, and then go ahead and output the variable. If I put the plus plus on the other side, what's called a postfix increment, we would output age and then add 1. But we want to add 1 first so we actually see the change. All right, oops, let's go ahead and save. Let's bring up our command line again. Oops, looks like it disappeared, so I'll go ahead and bring it back. And remember, I have that up arrow key, which can repeat previous commands. So we'll recompile. And now that we've recompiled, we'll go ahead and run it again. And it's added. Next year, I'll be 38. So the increment operator worked fine. Let's take a look at the modulus operator. System out print line. And let's say 17 modulus 4. Let's do 3. 17 modulus 3 equals. And then again, we'll concatenate, and we'll put in the parentheses the expression 17 modulus 3. So it works on the inside of the parentheses first, just like in every programming language. So that'll be evaluated and then output. So we'll see what the result of 17 modulus 3 is. Now, remember, it's the remainder after division. So 3 goes into 17 5 times with 2 left over. So we should see a value of 2 there. All right, so there's our command line. We'll recompile, and we will, again, run our program again. So 17 modulus 3 equals 2. Arithmetic operators. Now, the other type of operator you might commonly see with variables are combined assignment operators. Now, combined assignment operators actually perform an operation and then assign. So, combined assignment operators. And those look like this. For example, we have plus equals, which means add or concatenate, and then assign. We have minus equals, which is, of course, subtract, then assign. We have multiply, then assign. And then finally we have divide, then assign. I only use really add, then assign in my own programming. I don't think I've used most of the others very frequently at all. So let's go ahead and use one of our existing variables. Let's take our tennis score. And all we're going to say is tennis score plus equals, I guess in tennis you go from 30 to 40, so plus equals 10. Now this is the same thing as saying tennis score equals tennis score plus 10. It's essentially a shortcut. So now let's go ahead and output tennis score, and it should be 40 if we've done this right. There we go. All right, and one more time, let's go through the rigmarole here. We'll compile using our -D, so we compile in our directories from our package declaration. And then we'll run it using the fully qualified package name with the class, the fully qualified class name. And that includes the package. And there's tennis score equals 40. So our plus equals operator worked. All right, so this has been a very quick review of how variables work in the Java programming language.